right, so what we're going to look at today is 8.2, which is solving by graphing or solving by factoring using GCF. So we're going to look at a couple different ways. So for number one, the first thing we want to do is go back and review kind of some basic terms. Remember, GCF stands for greatest common factor, meaning what is the biggest number that will divide evenly into, for instance, on number one, 16 and 20. So in that case, the biggest number that I could divide by and get a nice pretty number for both would be 4. So 16 divided by 4 is a pretty number, 20 divided by 4 is a pretty number. If I go any higher than that, it doesn't go in evenly to both numbers. Now, if you look at number 2, start with the 12 and the 15. What's the biggest number that divides evenly into 12 and 15? If you said 3, you are right. Now, when we get to x squared and x cubed, I always think about it like, think about two people. One person's holding 2 x's and one person is holding 3. What is the most I could ask them for where they can both contribute? So for instance, if I said, hand me 4 x's, neither one of them could do that. What if I said, hand me 3 x's? Well, the guy with 3 x's could do it, but the guy with 2 couldn't, right? So the most I could ask where they could both contribute would be 2 of those x's, x squared. All right, look at number 3. What number divides evenly into 30 and 36? What's the biggest common factor? 6. Now look at the s's. This guy has 4, this guy has 3. So what's the most I could ask for? 3. It's always going to be your smallest exponent. Okay, now look at the t's. This guy has 4, this guy has 5. So how many can I ask where they could both contribute? 4. If I ask for any higher than that, then t to the 4th doesn't have it. So you just look for your smallest exponent. All right, number 4 wants us to kind of review distributive property because in a second, we're basically going to be doing that backwards. So if we look at number 4, you're going to start by distributing. So 5 times n squared is 5n squared. 5 times 8 is 40. Okay, let's try another one. I distribute here. This is kind of like negative 1 x cubed. So negative 1 times 9 is negative 9. Do you remember what you do when you multiply and they have the same base? Add the exponents. So x to the 3rd times x to the 4th is x to the 7th. All right, now distribute again. What's negative 1 times negative 2? It's positive 2. X to the 3rd times x to the 3rd is x to the 6th. You add those exponents. And then negative 1 times 7 is negative 7. And x cube's just there. We don't have anything to multiply them with. Try number 6 real fast. Multiply that out. See what you get. All right, if you need to, press pause and keep trying. But here I'm going to multiply. So negative 5 times negative 3 is 15. Y to the 2nd times y to the 3rd is y to the 5th. We add those. Negative 5 times 8 is negative 40. Remember, this is like y to the 2nd, or excuse me, y to the 1st. So y to the 2nd times y to the 1st is y to the 3rd. All right, now we get into where we need to combine those two concepts. What we're going to work on today is working on, instead of distributing and going from like here to here, we're going to work on going backwards. Let me pull out that GCF, and that's what we call factoring. When I kind of break it down into parts, I'm going to factor out that GCF. I'm going to pull it back out as if I'm kind of undistributing. So if you look at number 7, look at these two terms, 8x squared and negative 16. What is my GCF? What is the biggest number that divides evenly into 8 and 16? 8, right? 8 divided by 8 is 1. 16 divided by 8 is 2. I can't pull out an x because this 16 doesn't have an x to give. So that is not part of my GCF. All right, now we're going to open up a set of parentheses. Now imagine distributing. 8 times what would give me 8x squared? X squared, right? It's like I'm basically dividing. When you factor, it's like dividing. It's like saying, okay, I have 8x squared. I'm pulling 8 out of that. I'm left with x squared. Now, 8 times what would give me negative 16? Negative 2. Again, it's like you're dividing. I had a negative 16. I'm pulling an 8 out of that. That leaves me with negative 2. So your final answer is 8 times x squared minus 2. Okay, look at number 8. What number is my GCF for 14 and 35? 7. Now look at the ends. This guy has 2, this guy has 1. So always go with the smallest exponent. That means I can ask them to give 1. Okay, open up a set of parentheses. 7 times what would give me 14? 2. Now this guy had 2 ends, but we took one of them away, right? He gave them to us. So how many ends does he still have left? 1. Good. Minus 7 times what would give me 35? 5. Now this guy had 1 end, but he gave it to us, which means he doesn't have any ends left. So we are done. You can always double check yourself. Redistribute. 7n times 2n is 14n squared. 7n times negative 5 is negative 35n. Always double check. Redistribute. Make sure it gives you what you started with. All right, let's try number 9. Start with the numbers. So what's my GCF for 10 and 25? 5. All right, this is q to the first and q to the second. So how many q's can I pull out? 1, because we always go with our smallest exponent. All right, here we go. I had it 10, but I pulled a 5 out, right? So what's left? 2, because 5 times 2 would give me 10, right? I had a q, but we pulled him out, so he's gone. All right, 5 times what would give me negative 25? Negative 5. This one has 2 q's, but I'm pulling 1 out, so that leaves me with 1. Okay, so our answer here, so 5q times negative 5q would give you negative 25q squared. There's our answer. All right, now what we're going to use in a second is what's called the zero product property. So it says if you multiply 2 things together, so for instance, 4 times 5, that's 20, right? What's 3 times 0? 0. What's 0 times 5? 0. What's 7 times 1? 7. Well, what the zero product property says is it zones in on these cases, where the only way you are going to get 0 as an answer, as a product, meaning if I multiply 2 numbers, the only way I'm going to get 0 out is if one of the numbers is 0. 0 times something is going to give me 0. So the zero product property says if you multiply A and B and get 0, then either A is 0 or B is 0. So now go back to number 10. You're going to take each of these factors, these sort of pieces that are in parentheses here. Those are my 2 things being multiplied together. Well, the only way I multiplied them and got 0 is if either this was 0 or that was 0, right? One of them had to be 0. So we're going to set each one equal to 0. So either x plus 4 equals 0 or x plus 1 equals 0. One of those things had to happen, or both. It could be that both of them were 0. 0 times 0 is 0. Now you just solve it. So to undo subtracting 4, we add 4. Over here, to undo adding 1, we subtract 1. So what happens is I get 2 different answers. Either x is 4 or negative 1. If it's either of those numbers, then when I go to substitute back in, so for instance, let's say x is 4, well then 4 minus 4 is 0. Now I have 0 times something, and I'm going to get 0, right? Same thing if I were to plug in negative 1. Well, now this guy is 0, which means the whole thing is 0. All right, let's try another one. Look at number 11. Now, on number 11, we really have 3 things being multiplied together. We've got the 4, the 2x minus 3, and the x plus 5. Well, I know 4 doesn't equal 0. He can't be it, which means one of these other 2 has to be 0. So if I'm solving this, I'm going to add 3. And then divide by 2. And remember, at any point, you can pause this video. If I'm solving this equation, to undo adding 5, we subtract 5. So this 4 did not contribute at all. We know he's not 0, which means x is either 3/2, or you could put 1.5, or it's that -5 right there. All right, now look at number 12, kind of the same concept. The only things being multiplied here are the 2, and if you think about it, this x plus 4 squared, remember that means it's like writing it twice, right? It's being multiplied by itself. So there are really 3 things being multiplied together, but we know the 2 isn't 0, right? So he's kind of irrelevant. The x plus 4 could be 0. Or the third thing is again an x plus 4. I don't really need to write it twice. Once I've done the math, I've done the math. So if I solve this, I get x equals -4, and that is my only answer for that particular one. All right, let's try 13. So take each factor, set it equal to 0. One of those is 0, or both. How do you undo multiplying by 3? Divide. All right, what is 0 divided by any number? 0. All right, over here to undo subtracting 7, we're going to add 7. And our final answer is that x can be 0 or 7, either one, or both. Pause the video for a minute. I want you to try 14 and 15. And once you've done those and you've finished with them, then press play so you can check your answers. Okay, so on 14, we're going to set each factor equal to 0, each little piece that's being multiplied. Over here, we're going to divide. We get 0. Over here, we're going to subtract, and we get -2. So if you got 0 and -2, you were correct. On 15, you could set the -3 equal to 0, but then that doesn't happen. So we just X that out and say that doesn't happen. So then we just really have to focus on the x minus 5. So add 5, and we get x equals 5 is our one and only answer for that one. If x is any other number other than 5, that is not going to multiply out to give me 0. All right, so all of the ones we just did have been nicely factored for me. Usually what you're going to have to do is factor it first and then do what we just did. So we're going to kind of combine the two concepts. We've practiced factoring, we've practiced solving, now let's combine those two. So if you look at number 16, the first thing we want to do is factor it. We want to pull out a GCF. We'll get into more advanced factoring over the next couple days, but you always want to check for GCF first. That's your first thing to check for. So what number will go into 2 and 30? 2. This has x squared, this has x to the first. So pull your smallest exponent, so we're going to do x to the first. All right, so 2 times what would give me 2? Well, that's just 1, right? This guy had 2 x's, but we pulled one of them out. So how many x's are left? One of them. So imagine redistributing. 2x times x would give me 2x squared. 2 times what would give me -30? -15. Now this guy had 1x, but we pulled him out, so those x's are gone. Now this is still equal to 0, so we want to bring this down. Now, if you have an equation, if there is an equal sign, then I can now solve this. Notice back here when there was no equal sign, like on 7, 8, 9, there's no equal sign, so we couldn't solve. We could factor, but we couldn't do anything else. These have an equal sign, which means now I'm going to go further, and I'm going to set each factor equal to 0. And we're going to solve. So to undo multiplying by 2, we're going to divide. And to undo subtracting 15, I'm going to add 15. So So we get 0 and 15 as our answers. So notice there's an equal in my answer because there was an equal in the question. Back on 7 through 9, there was no equal in the question, so there's no equal in my answer. Okay. All right, let's try number 17. All right, what is the biggest number you can think of that goes into 7 and 35? 7. All right, now, I'm going to do something that might kind of help a little bit here. If you see a negative in the front, go ahead and factor that negative out. It just makes the math a little easier in the long run. All right, this guy had x squared. He had 2 x's. This term only had 1. So how many x's am I going to put in my GCF? 1. All right, open your parentheses. Well, the negative 7 got pulled out, so he's gone. This guy had 2 x's. We pulled one of them out, so that leaves me with 1 x remaining. Negative 7 times what would give me negative 35? Positive 5. Good. Make sure to double check it. So negative 7 times 5 is negative 35. He had an x, but we pulled him out, so that's it. Now set each factor equal to 0. Over here, to undo multiplying, we're going to divide. 0 divided by any number is 0. Over here, to get rid of the plus 5, I'm going to subtract. And you got your answer. You can always double check your answer by substituting those numbers back into your original equation. If you don't get out 0, something's wrong. All right, now on number 18, you have to be a little careful. 18 might be worth starring. Okay, let's star 18. To work these, you must get them equal to 0 first. Okay, so to solve by factoring, it must be equal to 0 first. So you either need to move the 30x or you need to move the 2x squared. Since this is a negative 2x squared, and I don't really want that to be negative anyways, I'm going to go ahead and just add 2x squared to both sides. Well, negative 2x squared plus 2x squared is 0. Over on this side, these are not like terms. This is x to the second, this is x to the first. So I'm going to put the biggest exponent first, put it in standard form. So that's 2x squared and a positive 30x. Once you have it equal to 0, then you can factor. So I'm going to pull out my GCF. So what number is my biggest number that will divide evenly into 2 and 30? 2. This is x to the second and x to the first. So we pull out the smallest exponent, so x to the first. 2x times what would give me 2x squared? X, right? Because I had 2 x's, but I pulled one of them out. 2x times what would give me 30x? Well, 2 times 15 is 30. I had an x, but he got pulled out, so that's it. All right, set each factor equal to 0. Remember, if there's an equal in the equation, you can solve it. If it's equal to 0, you want to solve. Oops, equal 0, sorry. Divide, we get 0. Over here to undo adding 15, what should I do? Subtract. And remember, if I'm going too fast, you can always pause the video or rewind and replay it, but you can pause the video if you need time to write. All right, let's try a couple more, and then I'm going to let you try some. So look at 19. What's the biggest number you can think of that divides evenly into 15 and 55? 5. And we're going to go with our smallest exponent, so we're pulling out x to the first. All right, well, 5 times what gives me 15? 3. I had 2 x's, but we pulled one of them out, so that leaves me with 1 x. 5 times what would give me negative 55? Negative 11, good. And I had an x, but he got pulled out, so that's it. And again, check by redistributing. I always do, every time. I say, okay, that's 15x squared minus 55x, so that works. All right, since it's equal to 0, we're going to set each factor equal to 0. Keep in mind, if this were any number other than 0, that would not hold true, okay? Just because two numbers multiply to 6 doesn't mean one of the numbers is 6, right? The only way this works is if it's equal to 0. All right, divide. What do I need to do first over here? Good, to undo, add it, subtracting 11, we need to add 11. And what's my next step? You said divide by 3, you're right. Notice this one is not a pretty answer. 11 over 3 is not a pretty number. It's not an integer, but that's okay. It's still fine. It's still a number. All right, what about on 20? What is the first thing you need to do? Get it equal to 0. That must be your first step. So I'm going to subtract 60x from both sides. So to undo the positive 60x, we're going to subtract. So I have 9x squared minus 60x. Over here, those kind of cancel. We're just left with 0. All right, pause the video. See if you can solve that one from there. Go ahead and press pause and then press play once you have the answer. Okay, so your GCF, biggest number that divides into 9 and 60 evenly, is 3, and we're going to pull out a single x. 3 times 3 would give me 9. I had 2 x's, but I pulled 1 away, so that leaves me with 1. 3 times negative 20 would give me negative 60, and I had an x, but he left the building. Set each factor equal to 0. Over here, you're going to divide and get 0. Over here, you would add 20 and then divide by 3. Now, I'm going quickly because you should have tried this problem on your own, but if you missed it and need to make corrections, go ahead and press pause and make any corrections you need to with that problem before moving on to 21. 21, you can leave as is, or you can rewrite it so the negative 3x squared comes first, but you don't have to. So for instance, if I look at 21, the biggest number that divides evenly into 3 and 6 is 3. My lowest exponent for x is 1, so we're going to pull that out. So 3 times what would give you 6? 2. I had 1x, but I pulled him out, so he's gone. All right, 3 times what would give me negative 3? Negative 1, good. And remember, if you're stuck, just divide it. Say, this is what I have. I pulled a 3 out of it. So that leaves you with negative 1. And I had 2 x's, but I pulled one of them away, so I'm still left with 1x, x to the first. Now set each one equal to 0, just like you normally would. It looks a little backwards over here. We're used to it saying x minus 2, but I'm going to work it the exact same way. Right, here we divide, right, and get 0. How do I solve this one? What should I do? You have a couple options. I could add x to both sides and be done. 2 equals x. Or what a lot of people do is try to get this 2. Now remember, this is a positive 2. So to get rid of that positive 2, you need to subtract it. And then what would we have to divide by to get rid of that negative? Negative 1. Good. Like I said, you could also just from here, when you've got that 2 minus x equals 0, you can also just add x to both sides, and you'll get to the same answer. So either way works. All right, 22. What's the biggest number that divides evenly into 12 and 30? Probably 6. Because I see this negative right here in the front, I'm going to go ahead and pull out a negative 6. And then again, you got 2 x's and 1 x, so we're going to pull out one of them. That part's pretty consistent with these today. All right, well, negative 6 times what would give me negative 12? Positive 2. Again, it's like saying I have negative 12 and I'm dividing a negative 6 out of that. I had 2 x's, but one of them left the building, so we're still left with one of them. Right. Negative 6 times what would give me 30? In other words, what's 30 divided by negative 6? Negative 5. And then we had an x, but he left. Again, check, redistribute. Make sure you get what you started with. All right, now we just set each one equal to 0. You're probably getting to be a pro at that part. Over here we divide and get 0. What would we do first on this side? You said add 5, you're right. What's my next step? Divide. All right, look at 23. What do I not like about 23? It's not equal to 0. We need it equal to 0. Probably the easiest thing to do is move this negative 3x, because that way I only have to move one thing. How do I move a negative 3x? Add 3x. And I'm going to put it right underneath his like term. All right, so these cancel, leave me with 0. Over here, 41x plus 3x would be 44x. And 22x squared has no like term to combine with. He just comes on down. All right, pause the video. See if you can solve it from there. Press play once you have it solved. All right, so we're going to pull out our GCF, which is 22x. That's going to leave me with x plus 2. Since 22 times 2 is 44. Set each factor equal to 0. Over here we divide. And over here we subtract. Now again, I'm going quickly because I'm assuming you've worked this problem. But if not, or if you need to make corrections, press pause so that you can get that work down before moving to 24. All right, 24 is a little bit different because you have that fraction in front. And I'm going to show you kind of 2 ways to approach it. I probably would not try to find the GCF of 1/3 and 7. That can get a little bit tricky. So instead, let's just focus on the x. This guy has 2, this guy has 1. So I can ask them both to give me 1, right? Now, what does that leave me with? Well, the 1/3 still hanging around. I hadn't done anything with him. He had 2 x's, but he gave me one of them. So he's still holding on to 1. Over here, the -7, still hanging around, hadn't done anything with him, but he did get rid of his x. He gave it up. So now set each factor equal to 0. This guy's done, right? That was easy, solved. How do I solve this? What should I do first? Add 7. How do you get rid of a 1/3? How do I undo multiplying by 1/3? Multiply by the reciprocal. You may have said divide by 1/3, which is not wrong, but remember to divide by a fraction, we multiply by the reciprocal. So if I flip 1/3 upside down, I get 3/1. These cancel, and 7 times 3 is 21. Kind of want to show you an alternate method here. Let's see if I can get to a better spot on my board. X squared minus 7x. So 1/3 x squared minus 7x. You don't have to write this, but I do want to kind of show it to you at least. One way that you can sometimes get rid of those fractions, we talked about this earlier this year, is to multiply by that denominator. So if I multiply everything through by 3, what happens is this just becomes 1x squared. 3 times negative 7x is negative 21x. I can pull my GCF out. And now I can set each one equal to 0. It doesn't so much save steps as it just keeps you from having to deal with that fraction the whole time. But notice either way, I get 21 and 0 as my answers. So either way is fine, but I wanted to at least show that to you because it is an option. All right, using graphs. This part should go pretty quickly here. One way we can solve a quadratic equation is by graphing it and looking at the graph. So for 25, they took this function and they graphed it. It's done for us. It's over here on the right. What are my x-intercepts? Okay, hopefully you said -3, 0, and 1, 0, right? Remember, intercepts are ordered pairs. Same thing if I go to 26. What are my x-intercepts? 0, 0, and 4, 0, right? Again, they're ordered pairs. Now, what if on your last test in Unit 7, I had said, what are the zeros? How would that have changed what you wrote? You would have done x equals -3 and 1, right? You would have just listed the x. Or over here, you would have said x equals 0 and 4. Zeros and x-intercepts are very similar, except that zeros or roots are just the x's. All right, now let's say I asked you to solve. What if I had given you this equation earlier in the page, right? Well, you would have set each factor equal to 0. Well, we know this negative is not 0. So let's set x minus 1 equal to 0, x plus 3 equal to 0. So I add 1. Over here, I subtract 3. Okay, so I got 1 and -3, or -3 and 1. Why does that answer look really familiar? It's the same thing I got with my zeros, right? Notice over here what happens if I try to solve this equation. Set each factor equal to 0. So x equals 0, that's solved. And over here we add 4. Well, voila, those also match, right? When you solve a quadratic equation, it is where your graph crosses the x-axis. Because if you think about it, you're saying, I want my output to be 0. Well, the only put your output, or y, the only place your output or y is 0 is on the x-axis. That's where you got outputs of 0. So what you're looking for is where your graph, I can't talk today, your graph crosses the x-axis. So look at 27. They want the solution. This is no different than if I said, so find the roots, find the zeros. So all I have to do is look and say, well, this crosses the x-axis at 1 and 2. Those are the two x values that if I plugged in would give me 0. What do you think 28 is? X equals what? You said 6 and 8. You are absolutely correct. And you guys did a great job last unit of finding those zeros when you were given the graph. This is the same thing. 29, where does that cross the x-axis? It's like -6 and -1. Now, just like we did last unit, it is possible for a graph to only touch it once or to not touch it at all, in which case you would have no solution. 30 through 32 are the same thing, except we're going to use our graphing calculator. Now, when you type something like this into your graphing calculator, you don't want to type the equal to 0. You're just going to type y equals x squared minus 6x plus 8. Go ahead and pause the video. And I want you to type y equals x squared minus 6x plus 8. Type that into Desmos. Make sure you get the same graph you're seeing on my screen right now. All right, hopefully you have it in Desmos. If not, press pause. But you're going to click on those x-intercepts, those zeros. Now, it's going to give me intercepts. All we're going to do is give the x's. If you think back to all the ones we solved today, we just did x equals. So in this case, it will be x equals 2 and 4. And it doesn't matter what order you list those in. All right, so for 31, type y equals x squared plus 1. Graph that into Desmos. Go ahead and press pause and graph that. Press play when you're done. Okay, if I'm looking at that graph, where does it cross the x-axis? It doesn't, right? Which means there is no place where this equation is ever going to be 0. So we put no real solution. no real solution. There is something called imaginary numbers. We're not getting into it, but that's the reason we have to put that word real in there, because we're trying to be mathematically correct. There are other solutions. They're just what we call imaginary, and we're not getting into that. So we're just going to put no real solution. All right, and then 32, we're going to graph the part that's not equal to 0, so 3x squared. Go ahead and graph that in Desmos. All right, if I graph that, notice it only crosses the x-axis once, at 0. That's it. So our answer is just x equals 0. So you could have one solution, two solutions, like we did over on number 30, right? There were two answers, or you could have no solution. No real solution. All right, and then 33 through 36, which is the last part of your notes. Go ahead and pause the video. See if you can match these up. You want to try to match the graph, and then based on the graph, give the answer. Press pause, see if you can get that answer, and then press play once you're done. Okay, so hopefully you have tried these on your own. Let's start with the ones that open up, which is A and C. Okay, those are the two graphs that open up, which means I'm looking for a positive leading coefficient, like on 33 and 34, right? These are both positive ones in front. Now, if I look at 33, that's in factored form. So if you go back to last unit, remember this is intercept form. X minus 4 is going to cross at positive 4, right? X plus 3 is going to cross at negative 3, which it looks like that's happening on A. So this is A. And remember, your answers are exactly where it crosses the x-axis, so negative 3 and 4. That kind of by default leaves C, which makes sense. This is just your basic parabola that has been shifted up 3, which is what happened on C. What is your solution? Where does that cross the x-axis? It doesn't, so no real solution. Remember, we want that word real in there. 35 and 36 are your ones that are opening down, so that's going to be B and D, right? So if I'm looking at 36, for instance, this again is like having vertex form, right? So if I do opposite same, opposite of negative 3 is positive 3. Same as what's on the outside is 0. And you can also use Desmos to help you. Notice the only place it crosses the x-axis is at 3. And then obviously that makes this B. That's a parabola that's been flipped upside down and then shifted up 4. That's what that plus 4 does. He crosses the x-axis at negative 2 and 2. Sometimes you'll see us kind of shorthand that as plus or minus 2. Either notation is fine. All right, and that leads us to your classwork. So just check with your teacher that your classwork is in your packet.